A salesman is handing out brochures at the main entrance of a shopping center. He knows that the probability of a person taking the brochures is 0.3. Question A. At a certain hour, 50 people have entered the shopping center. First, determine the probability more than 10 people took the brochures. Second, if the probability more than K people took the brochure is 0.9975, determine the value of K. Third, if the probability at least one brochure was handed out is more than 0.9, determine the minimum number of people that have entered the shopping center. Question B. If 200 people have entered the shopping center in a certain hour, approximate the probability that more than 55 brochures were handed out. So, if we can see here for question A, 50 people have entered the shopping center, and from the second sentence, he knows that the probability of a person taking the brochures is 0.3. From this question 1, probability more than 10 people took the brochures. It means that our X is the number of people took the brochures. And our distribution is binomial, where n is 50 and our p is 0.3. Now for the first question, determine the probability p more than 10 people took the brochures. So x is more than 10. So we can't read from the table because the symbol is greater than. So we need to take the number after 10, which is x greater than or equals to 11. So let's look from the table. So n is 50. And p is 0.3. X is greater than or equals to 11. Then the probability is 0.9211. Question number 2. If the probability more than K people took the brochures is 0.9975, we can write down as probability X is more than K people who took the brochure is 0.9975. Determine the value of K. So to read the table, just like the first question, if it's x is greater than 10, we're going to write down x is greater than or equals to 11, where we add 1 to 10. So to read from table means we need to write down x greater than or equals to k plus 1, which is equals to 0.9975. Now let us read from the table. What is the probability of 0.9975? So let us find where is the probability of 0.9975. 0.9975, and we're going to get the variables 7. We can write down as probability x greater than or equals to 7, which is equal. If the probability at least one brochure was handed out is more than 0.9, so we may write down as probability of x more than or equals to 1 is more than 0.9. At least 1. So the symbol is more than or equals to. So let us draw some number line. The binomial distribution start with 0, 1, 2, until n, and we are looking for x is greater than or equals to 1. So what we can do is the complement, which is 1 minus with probability of x equals to 0, then we're going to get 0.9 here. So if we simplify, probability of x equals to 0 is less than 1 minus 0.9 is 0.1. Now we can use the formula n C0 times with 0.3 to the power of 0 times 0.7 to the power of n less than 0.1. So the value of NC0 and 0.3 to the power of 0 is 1. So we're left with 0.7 to the power of n less than 0.1. Let us log both sides to find the value of n. So log 0.7 n less than log 0.1. So using the property of log a to the power of b is b log a, then we can write down n log 0.7 less than log 0.1, and n is greater than log 0.1 divided with log 0.7. We need to change the symbol because the value of log 0.7 is negative. So let us find the value. Log 0.1 divided with log 0.7 is 6.456. Therefore, n equals to 7. What is n? N is the minimum number of people that have entered the shopping center. If 200 people have entered the shopping center in a certain hour, approximate the probability that more than 55 brochures were handed out. So what we have to do now is to write a new distributions because the parameter changed from 50 to 200 people. So x has binomial distribution where n is 200 and p is still the same, which is 0.3. So our n has become extremely large, which is n is greater than 50. So let us approximate to normal distribution. Okay, so we're going to write down x has normal distribution. So here we're going to find mean, which is NP, and variance, NPQ. So 200 times with 0.3 is 60, and 200 times 0.3 times with 0.1 minus 0.3 is 0.7, which is 42. So what's the question? Probability more than 55 brochures were handed out. So probability of X more than 55. So let us do the continuity corrections first. So this is 55. The symbol is greater than. So we would like to exclude 55. So we're going to take the value after 55, which is we add 0.5 to 55. We're going to get X is greater than 55.5. So next is standardize. So Z is greater than 55.5 minus 60 divided with 42. Then probability of Z is greater than 55.5 minus 60 divided with square root of 42 is negative 0.69. Correct to 2 decimal places. Let's draw some bell shape. The 0 here, negative 0.69. The z-score is negative, so it's going to be on the left of 0. Let us shade. So how to find this probability of z greater than negative 0.69 is we're going to take whole total probability, which is 1, and we're going to minus with this white area here. So if this is probability of z greater than negative 0, probability of z greater than negative 0.69 means this area here is probability of z less than negative 0.69. So we can write down as 1 minus, let us symmetric this white area to the right side. So we're going to get probability of z greater than 0.69. So by using the standard normal table, the z-score is 0.69. So 0.6 plus with 9, 0.69, so it's going to get 0.2541. So 1 minus 0.2451, sorry. So 1 minus 0.2451, the probability is 0.7549. So that's it.